past essay questions on discrete random variable. I will solve 5 past essay questions on discrete random variables. This is the first question. The probability mass function P of a discrete random variable x is defined as P of x equals to x is equals to C over 2 into 1 plus x for x equals to 5 and 6, C into 11 minus x for x equals to 7, 8, 9 and 10, and 0 otherwise. A. Find the value of the constant C. B. Construct the probability distribution table for x. C. State the mode of x. D. Find the mean and variance of x. E. Construct a cumulative probability distribution table for x. A. Find the value of the constant C. You know, by definition, for x to be a discrete random variable, the summation of the probabilities of x must be equals to 1 for all values of x. The all values of x in this question starts from x equals to 5 to x equals to 10. You know, this is the probability mass function, and this probability mass function is a step function in this case. That is, it is having 3 pieces or 3 steps. This is the first step, this is the second step, and this is the third step. To compute the probability mass function for each step, I am going to take the values of x for that step and substitute in the function given. For this piece of function, the values of x are 5 and 6. And for this piece, the values of x are 7, 8, 9, and 10. For this piece, the probability mass function of x is 0. Thus, for values of x not in the range from 5 to 10, the probability mass function is 0. This formula means probability of x equals to 5 plus probability of x equals to 6 plus probability of x equals to 7 plus probability of x equals to 8 plus probability of x equals to 9 plus probability of x equals to 10. For probability of x equals to c all over 2 into 1 plus x, the values of x are 5 and 6. So it means for probability of x equals to 5, I'll have c over 2 into 1 plus 5. That means in place of x I put 5, which will simplify to 6c all over 2, since 1 plus 5 is 6. 6 times 5 is 6c all over 2. Now, for probability of x equals to 6, I'll have c over 2 into 1 plus 6, which simplifies to 7c over 2. That's 1 plus 6 is 7. 7 times c is 7c over 2. It means that here will be 6c all over 2 plus 7c over 2. Now, for the other piece, the probability of x is c into 11 minus x, and the values of x for this piece are 7, 8, 9, and 10. It means that for probability of x equals to 7, I will have c into 11 minus 7, which is 4c. 11 minus 7 is 4. 4 times c is 4c. Now, for the probability of x equals to 8, I'll have c into 11 minus 8. 11 minus 8 is 3. 3 times c is 3c. Now, for the probability of x equals to 9, I'll have c into 11 minus 9. 11 minus 9 is 2. That is 2 times c is 2c. It means that here is 4c plus 3c plus 2c. Now, for the probability of x equals to 10, I'll have c into 11 minus 10. 11 minus 10 is 1. So 1 times c is c. So it means here is c. All this equals to 1. Equals to 1 here. So I need to sum all these values and equate to 1. To sum these two fractions, I can just add the numerator since the denominators are the same. That's 6c plus 7c is 13c all over 2. Now 4c plus 3c is 7c. 7c plus 2c is 9c. Plus 1c is 10c. That is plus 10c. All that equals to 1. Now to simplify this, I can cross multiply. That is 13c all over 2 times 2 plus 10c times 2 is equals to 1 times 2. As I multiply everything by 2 so that these 2 can cancel out, and I have 13c plus 20c equals to 2. Now 13c plus 20c is 33c, which is equals to 2. Now I divide both sides by 33, so to cancel out this 33, and then c will be equals to 2 over 33. That is c is 2 over 33. That is c is equals to 2 over 33. B. Construct the probability distribution table for x. The probability distribution table is a table showing the values of x and its corresponding probabilities. That is a table like this, where these are the x values. This is the rule for the probabilities of x. You know, from the A part of the question, the probability of x equals to 5 is 6c all over 2. That means here is 6c over 2, but I need to simplify. I know c is 2 over 33 as I got from the A part. That means the probability of x equals to 5 is equals to 6c over 2. Now in the place of c, I'll put 2 on 33. That is 6 over 2 times 2 over 33. Now this 2, we cancel this 2, and I'll be left with 6 over 33. It means in the place of x equals to 5, the probability is 6 on 33. Now for x equals to 6, the probability as from the A part of the equation is 7c over 2. That means the probability of x equals to 6 is equals to 7c over 2. Now in the place of c, I'll put 2 on 33. That is 7 over 2 times 2 on 33. 2 cancel out here. I'll be left with 7 all over 33. That means when x equals to 6, the probability is 7 over 33. Now the probability when x equals to 7 is 4c. That is probability of x equals to 7 is equals to 4c. That is 4 into 2 over 33. That is 4 times 2 is 8. We have 8 over 33. It means here is 8 over 33. Now the probability of x equals to 8 is 3c. That is probability of x equals to 8 is equals to 3c. So which is the same like 3 times 2 on 33. 3 times 2 is 6. That means it is 6 over 33. So it means that here is 6 over 33. Now the probability of x equals to 9 is 2c. That is the probability of x equals to 9 is equals to 2c. So I'll have 2 times 2 on 33. 2 times 2 is 4. So it means this is 4 on 33. So it means here is 4 over 33. Now the probability of x equals to 10 as from the A part of the equation is c. That is the probability of x equals to 10 is equals to c, and c is 2 on 33. So it means here is 2 over 33. So this is the probability distribution table for x as required. Now C, state the mode of x. By definition, the mode is the value of x with the highest probability, and from this table the highest probability is 8 all over 33. So I compare these fractions. Since they are having the same denominators, I choose the one with the biggest numerator, and that is this one. Since the numerator is 8 and the value of x corresponding to this is 7, so it means mode of x is 7. D. Find the mean and variance of x. To find the mean, I need to state the formula, but you know, mean is the same like the expectation of x, and the formula for the expectation of x is equals to the summation of x times the probability of x for all values of x. I know the all values of x here are from 5 to 10. That is the summation from x equals to 5 to 10. That means the expectation E of x is equals to x times probability of x equals to 5 plus x times the probability of x equals to 6 plus x times the probability of x equals to 7 plus x times the probability of x equals to 8 plus x times the probability of x equals to 9 plus x times the probability of x equals to 10. That is x times the probability of x equals to 5 is equals to 5 times the probability of x equals to 5, which is 6 over 33. That means 5 times 6 is 30, so it means 30 all over 33. So here is 30 all over 33. Now for x times the probability of x equals to 6 will be 6 times 7 over 33. That is 6 times 7 is 42. So 42 all over 33. Here is 42 all over 33 plus x times the probability of x equals to 7 from the table is equals to 7 times 8 over 33. 7 times 8 is 56, so it means 56 over 33. So here is 56 over 33. Now for x times the probability of x equals to 8 from the table is this one, which is 8 times 6 over 33. 8 times 6 is 48. That is 48 all over 33. Means that here is plus 48 all over 33. Now for x times the probability of x equals to 9 from the table is this, which is equals to 9 times 4 all over 33. 9 times 4 is 36. That is 36 over 33. So it means here is plus 36 over 33. Now for x times the probability of x equals to 10 from the table is this. That is 10 times 2 over 33, which is equals to 20 all over 33. So it means here is plus 20 over 33. So to get E of x, I need to add all these fractions. You know, to add these fractions faster is just to add the numerator since the denominators are all the same. That means E of x is equals to 30 plus 42 plus 56 plus 48 plus 36 plus 20 will give me 232. That is 232 over 33 is the value of E of x. Now the next thing is to calculate the variance of x, and to do this the first thing is to state the formula of variance. That is, the variance of x can be calculated from the formula E of x squared minus E of x all that squared. Now, I know E of x, but I don't know E of x squared. So, I need to calculate E of x squared. I know E of x squared can be calculated from the formula the summation of all x, which in this case is from x equals to 5 to x equals to 10 of x squared times the probability of x. That means E of x squared is equals to x squared times probability of x equals to 5 plus x squared times probability of x equals to 6 plus x squared times probability of x equals to 7 plus x squared times probability of x equals to 8 plus x squared times probability of x equals to 9 plus x squared times probability of x equals to 10. That is x squared times the probability of x equals to 5 is equals to 5 squared times 6 over 33 from the table. That is 6 over 33. 5 squared times 6 is 150. So it means this is 150 over 33. So for this term, we have 150 over 33 plus x squared times the probability of x equals to 6. That is 6 squared times 7 over 33. That is 7 over 33. 6 squared times 7 is 252. That means this is 252 over 33. Means that here is plus 252 over 33 plus x squared times the probability of x equals to 7, which is 7 squared times 8 over 33. That is 8 over 33. Which is equals to 7 squared times 8 is 392 over 33. So here is 392 over 33 plus x squared times the probability of x equals to 8, which is equals to 8 squared times 6 over 33. That is 6 over 33. 8 squared times 6, that is 384 over 33. That means here will be plus 384 over 33 plus x squared times the probability of x equals to 9. That is 9 squared times here, which is 4 over 33. Squared times 4 is 324. That is here 324 over 33. That means here is plus 324 over 33 plus x squared times probability of x equals to 10, which is 10 squared times this one, that is 2 over 33, which is equals to 10 squared times 2 is 200. That is 200 over 33. So it means here is 200 all over 33. Now to get e of x squared, I need to add all these fractions. I see all these fractions are having the same denominator. The fastest way to do this is to add the numerators and take it all over 33. That means e of x squared is equals to 150 plus 252 plus 392 plus 384 plus 324 plus 200, which will give me 1702. That is e of x squared is equals to 1702 all over 33. Now I've gotten e of x squared and e of x, so I can now calculate the variance. That is the variance var x is e of x squared minus e of x all squared. That means in the place of e of x squared, I'll put this fraction. That is 1702 all over 33 minus 232 all over 33 all squared. That is 1702 all over 33 minus 232 all over 33, all that squared will give me approximately 2.15. That means the variance of x is approximately 2.15 in 2 decimal places. The e part of the equation. You know the cumulative function of a random variable x is symbolized capital F of x. A cumulative probability distribution table is a table showing the values of x and its cumulative probabilities. That is a table like this. The cumulative table can easily be obtained from the probability distribution table, I mean this table that I constructed in the B part of the question, you have to know that by definition, if x1 is the first x value in the probability distribution table, it means the cumulative value of that x1 should be equals to the probability of x1. In this case, x1 is equals to 5 from this probability distribution table. That's the first value of x in the table from left to right. That means from this formula, the cumulative value of x1, which is 5, should be equals to the probability of x equals to 5, which is this value, that is 6 over 33. It means that here is 6 over 33. You also know that if the last value of x in the cumulative distribution table is xn, then the cumulative value of that last value will always be 1. The last value of x from left to right in this table is 10. That means the cumulative value of 10 is equals to 1 from this formula. That is, here is 1. You also need to know that for any value, let's say xn, then the probability of x equals to xn is always equals to the cumulative value of xn minus the cumulative value of xn minus 1. xn minus 1 is the previous value before xn. What I'm trying to say is that if you wish to calculate, let's say, the probability of x equals to 5, then it will be the same like f of 5 minus f of 4. Now we need to calculate f of xn. That is, we need to calculate the cumulative values, not the probabilities. Since we know the probabilities, so we need to calculate the cumulative value. So I need to make f of xn to be the subject of the formula. That is, from this formula, f of xn will be equals to the probability of x at xn plus f of xn minus 1. Since minus f of xn minus 1 becomes positive when it crosses the other way, that means f of 6 is equals to the probability of x equals to 6 plus f of 5. You know, probability of x equals to 6 from the distribution table is this, and the cumulative value of 5 is this. That means we have here 7 over 33 plus 6 over 33. These fractions have the same denominator, so I can just add the numerators. That is 7 plus 6 is 13. That is 13 over 33. It means here is 13 over 33. Now f of 7 from this formula is equals to the probability of x equals to 7 plus the cumulative value of 6. That is, the probability of x equals to 7 is this value plus the cumulative value of 6, which is this. That means I will have 8 over 33 plus 13 over 33. Now I add the numerators. 8 plus 13. That is 21 over 33. It means that here is 21 over 33. Now I need to calculate f of 8. From this formula, f of 8 is equals to the probability of x equals to 8 plus f of 7. That is, the probability of x equals to 8 from this table is this, and f of 7 is this. That is 6 over 33 plus 21 over 33. Now I add the numerators and I take over 33. That is 6 plus 21 is 27. Is equals to 27 over 33. That means for f of 8, I'll have 27 over 33 here. Now for f of 9, from the formula will be the probability of x equals to 9 plus the cumulative value of 8, which is this one plus this one. That is 4 over 33 plus 27 over 33, which is 4 plus 27, 31. 31 all over 33. That means here is 31 all over 33. So this is the cumulative probability distribution table of X. Number 2, a discrete random variable has probability distribution as shown below. That is, X values are 0, 1, 2, 3, and 4, and the probabilities of the values of X are 3 over 25, 3 over 20, T, 1 over 4, K. It is known that the expectation of X or E of X is equals to 101 over 50. Find A, the values of T and K, B, the variance of X. You know, the expectation of the random variable X can be obtained by the formula summation of X times the probability of X for all values of X. In this case, X ranges from 0 to 4. That is, the summation from X equals to 0 to 4 of X times the probability of X is equals to 101 all over 50 as stated in the equation. That is 0 times the probability of X equals to 0 plus 1 times the probability of X equals to 1 plus 2 times the probability of X equals to 2 plus 3 times the probability of X equals to 3 plus 4 times the probability of X equals to 4. All this is equals to 101 divided by 50, which is 2.02. That means 0 times 3 over 25, since the probability of X equals to 0 is 3 over 25. That is 0 times 3 over 25 plus 1 times 3 over 20. That is 1 times 3 over 20 plus 2 times T, since the probability of X equals to 2 is T, plus 3 times 1/4. That's the probability of X equals to 3 is 1/4 plus 4 times K. For X equals to 4, the probability is K as from this table. All this is equals to 2.02. That means 0 times 3 over 25 is 0. Now 0 plus 1 times 3 all over 20 is 0.15. That is 0.15 plus 2 times T, which is 2T, plus 3 times 1 over 4. That is 3 times 1 all over 4 is 0.75 plus 4 times K, which is 4K. All this is equals to 2.02. That means 2T plus 4K is equals to 2.02 minus 0.15 minus 0.75, which means 2T plus 4K is equals to 2.02 minus 0.15 minus 0.75 is equals to 1.12. Now let's call this equation 1. You know that for a random variable X to be a discrete random variable, it means that the summation of the probability of X for all values of X must be equals to 1. And here the values of X here are from 0 to 4. That means the summation from X equals to 0 to 4 of the probability of X must be equals to 1. That is, probability of X equals to 0 plus probability of X equals to 1 plus probability of X equals to 2 plus probability of X equals to 3 plus probability of X equals to 4 must be equals to 1. But you know that the probability of X equals to 0 from this table is 3 over 25. That is 3 over 25 plus 3 over 20 for the probability of x equals to 1, plus t, which is the probability of x equals to 2, plus 1/4, which is the probability of x equals to 3 from the table, plus k, the probability of x equals to 4. All this equals to 1. That means k plus t is equals to 1 minus 3 all over 25 minus 3 all over 20 minus 1/4. Since 3 over 25, when it goes to the other side of the equal sign, it becomes negative. This one goes to the other side of the equal sign, it becomes negative. The same for 1/4, it crosses the equal sign, it becomes negative. That means k plus t is equals to 1 minus bracket 3 all over 25 bracket close minus bracket 3 all over 20 bracket close minus 1 all over 4 bracket close. So that is 0.48. So here I have 0.48. Now this is equation 2. So I'm going to solve now equation 1 and equation 2 to obtain the values of k and t. You know, this is the equation 1 that we obtained before. Now if I take 2 times equation 2 minus equation 1, t is going to cancel out. That is 2 times equation 2 is 2k plus 2t is equals to 2 times 0.48, which is 0.96. That means here is 0.96. Now minus equation 1, that is I'll have 4k here plus 2t is equals to 1.12. Now if I subtract, I'll have negative 2k here. That's 2 minus 4 is minus 2. That's minus 2k. 2t minus 2t is 0. That's equals to 0.96 minus 1.12. And here I'm going to have negative 0.16. That means minus 2k plus 0 is minus 2k is equals to minus 0.16. Now if I divide both sides of this equation by negative 2, that's negative 2. Here this will cancel out and I'll have k is equals to negative 0.16 divided by minus 2, which is 0.08. So k is 0.08. To get the value of t, I can substitute k equals to 0.08 in either equation 1 or equation 2. Now, if I substitute k equals to 0.08 in equation 2, I'll have 0.08 plus t is equals to 0.48. That means t will be equals to 0.48 minus 0.08. That is 0.48 minus 0.08 is 0.4. That is t is equals to 0.4. So the value of t is equals to 0.4 and the value of k is equals to 0.08. Now b, the variance of x. You know, the formula to calculate var x is e of x squared minus e of x all squared. Now, from the equation, e of x is 101 over 50, but I don't know e of x squared, so I need to calculate it. I know the formula to calculate e of x squared is equals to the summation of all x. I know all x here is from 0 to 4. That is the summation from x equals to 0 to 4 x squared times the probability of x. That is 0 squared times probability of x equals to 0 plus 1 squared times probability of x equals to 1 plus 2 squared times probability of x equals to 2 plus 3 squared times probability of x equals to 3 plus 4 squared times probability of x equals to 4. That means e of x squared is equals to 0 squared times the probability of 0 is 0. That's 0 plus 1 square is 1 times probability of 1 from the table is 3 all over 20, and then 2 squared is 4 times the probability of 2, which is t from the table, plus 3 squared, which is 9 times the probability of x equals 3, which is 1/4 from the table. That is 9 times 1 over 4 plus 4 squared times the probability of x equals to 4, which is k. That means 4 squared is 16 times k is 16k. That means e of x squared is equals to 3 all over 20 plus 4 times t. T is 0.4 as from the a part of the equation, plus 9 times 1/4, which is 9 over 4. Now plus 16 times k. K is 0.08 from the a part of the equation. That is, here is 16 times 0.08. That is, the expectation of x squared is equals to bracket 3 all over 20 bracket close plus 4 times 0.4 bracket close plus 9 all over 4 plus bracket open 16 times 0.08 bracket close. The final answer here is 5.28. That means e of x squared is equals to 5.28. Now I need to look for the variance, but you know that e of x is 101 all over 50. That is, e of x is 101 divided by 50, which is 2.02. Now e of x is 2.02 and e of x squared is 5.28. Now I need to substitute in this formula of the variance. That means var x is equals to e of x squared, which is 5.28 minus e of x all squared, that is 2.02 all squared, which is equals to 5.28 minus bracket 2.02 bracket close squared will give me the variance as 1.1996.